Hey everyone, welcome back. In this lecture, we'll create our first query, which will extract data from the database that we imported last time. And to do this, we'll use the select and from statements. We'll also then, after this, learn how to filter the selected data using the where statement too, which lets us filter records based on a given condition. Let's move on over into SQL Server Management Studio and get started. Okay, so here I am back in SSMS. To create our first query, let's come up to the top here and select New Query. Alternatively, we could also use the shortcut for this, which is Ctrl+N. And this will create a new window where we can write our SQL query. One thing to mention here is that currently this query will run against our master database. We can verify this up here from the top left. Where it says master within this drop-down menu, we'll need to change this to our AdventureWorks database, which we can do by clicking into this menu and selecting it. For our first query, let's say that we want to retrieve information about our employees. This information can be found in the human resources.employee table, which we can see here. To help us write this query, we can actually view all of the columns in this table by opening up the table itself by clicking on the plus icon, and then from in here we can open up the columns folder. This will let us see all of the different columns in this table, so we can choose what columns we might need or want to select. I'd just like to see all of the different logon IDs for each of our employees, which if we check over here in the Object Explorer, this column is called Login ID. I'll start our query by saying select. Select is a statement in SQL that allows us to retrieve data from a table inside of a database by specifying the columns that we want to retrieve. We wanted the login ID, so select and then login ID, like so. And I'm making sure here that this is entered in the exact same way with the same capitalization as it is in our columns. And while this would work with differently capitalized columns, it is considered best practice to copy it exactly. The next part of this is to actually specify where this column is coming from. So I'll add in from, and in this case, it's coming from the human resources.employee table. So I'm just going to type in human resources.employee. And we can see that as we go through here, SSMS is smart enough to provide some recommendations on what column we might be wanting. Okay, and that is our first query complete. And it's just going to query or select all of the data from the login ID column of our human resources employee table. To run our query, we can come up to the top and click on execute, or use the F5 shortcut, which is what I tend to do because it's quicker. I'll go ahead and press F5, and then we can see that our query has been executed. We can see this message here that says query executed successfully, but more noticeably, we now have a load of data here, which is showing us the login ID for each employee. Great job. So you've now created and executed your first SQL query. But let's say that now we actually want to select multiple columns from this table, and not just their login ID. To do this, all we'll need to do is pass in a comma after our first column, and then we can type in any of the other columns that we want from this table. I'll select both the national ID number and hire date columns. Alternatively, instead of specifying a column name, we could also pass in an asterisk, and that will select all of the columns in the table, which can be a helpful shortcut. However, for very large databases with lots of data, this can be a problem, as doing this will pull every single column and every single row from the table, which, depending on the level of performance from the SQL Server, could result in some performance issues. One thing that you can do is to select only a given number of rows. And to do this, we use the top keyword, which is just used to limit the number of rows returned from the query result. Currently, this query has returned a total of 290 rows, which we can see down here in the bottom right-hand corner. If we only wanted to return the top 60 rows, we could just pass in top, open a set of parentheses, and then pass in 60 or any other number that you wanted. And now when we run this, we only get 60 rows returned. Or if I set this number to 35, we'd of course only get 35 rows returned. And this would also work if we selected specific columns too, and not just all columns. Let's now quickly have a look at another topic in SQL, which is aliasing. Aliasing can be used to give our tables or columns temporary names in order to make them easier to read and work with. As a very simple example, let's take two of our columns here. So the national ID number and a hire date. Instead of these names, I'd like to call them NI number, so short for national insurance number, and joining date respectively. All we'll need to do is go back to our select statement, and after the column that we want to rename, I'll say as, and then pass in the new column name, which for this one will be NI number, and for hire date will be joining date. Okay, nice one. So you could set these aliases to whatever you want, but usually it's done just to make things a little easier to read. Something just to add here is that if you want to give a column a name that has a space in it, you'll need to wrap the alias in quotes, or you'll get an error. Before we move on to our next topic, let's just have a quick look at one more example, just to help clarify what we've done here. We'll do this in just the same way as before, so selecting the column name and then which table the data is coming from. For this example, I'm going to select the country region code from our sales.sales territory table. Okay, nice one. Before moving on to the where statement, there's one more thing that I want to show you, and that's the distinct keyword, which allows us to remove duplicate rows from our results. If we take a look at the results of our current select query, we'll see that there's quite a few different rows with a repeated region code of US. If we only wanted to select the non-duplicate values, we could just pass in distinct before our column name, like so. And then that'll only select one of each region code, like we can see here. And this now brings us onto the final topic for this lecture, which is the where statement. The where statement can be used to filter records or rows that meet certain criteria, which is very helpful for when we want to only return rows that are in a particular group. I'm going to start by selecting all of the columns in our human resources.employee table. In here, there's a column called job title. And let's say that we only want to select employees who have a job title of marketing specialist. At the end of our query, I'll type in the where statement, and then I'll pass in our condition, which is done in a very similar way to how we set our conditions in Python and Excel. So our column, which in this case is job title, an equals sign, and then we'll say where it's equal to marketing specialist. So now this is only selecting and returning employees who had a job title of marketing specialist. Alternatively, we could also say where our job title is not equal to this with an exclamation mark and equal sign. All of the basic Boolean logic operators that we've looked at so far will also work too. So for instance, we could say that where the job title is marketing specialist or marketing assistant. And then we could add in as many of these as we need. As we start to add more and more conditions in here, our query can start to become quite hard to manage and read. So what we can do instead is replace all of these OR statements with in. I'll replace our equals with in, open a set of parentheses, and then what I'll do is wrap all of our conditions inside of these parentheses. One of the main benefits of doing it this way is that we don't need to say for where state is equal to for each condition. We can just pass them all into this single set of parentheses. We could also replace in with not in too. It's also possible to use and in our SQL statements too. I'm working through these examples quite quickly here because it's the exact same logic that we've covered in Excel and Python, but just with a slightly different syntax. But hopefully, this should still be fairly straightforward for you. If you wanted to select employees who were marketing specialists, but who were also married, we could say where job title is equal to marketing specialist, but then also where marital status is equal to M, which is short for married. And when we run this, it'll now return the 3 employees that met both of these conditions. We can evaluate other conditions with our where statement too, such as numerical and date conditions. For example, we could say where the business entity ID was greater than 100, or where the organization level was less than or equal to 2. For these to work, we'll need to make sure that our columns have a numeric data type, but if you're working with an existing SQL database, then this will already have been set up for you. So all you'll have to worry about is actually querying the data. Finally, I'll show you how we can filter our data, but on date columns. In this table, we've got 2 date columns, the birth date and hire date. Let's say that we want to look for employees who were born in 1960 or before, so that we can identify any employees who might be retiring soon. We'll use the where statement again, but then for the condition, we'll say less than, but then for the actual date, we'll need to wrap this inside of quotes. And also, we can't just say 1960, we need to specify the full date in the format that's in our database. So the year, a hyphen, the month, another hyphen, and then the day. I'll say 1960, and then January the 1st, like so. And this will then return all of our employees who were born before 1960. And of course, we could also say either after or on this day too. So basically, conditions in SQL work in the same way that they do in Python and Excel. So you shouldn't have any problems with getting used to these. Okay, and that wraps up our lecture on how to query and select data from SQL databases. We've covered the select, from, and where statements, and used them to pull data from a number of different tables in our database. And then at the end, we've also used the where statement to filter this data too. I hope this lecture has made sense. In the next one, we're going to move on and have a look at how to join, group, and merge our data too, as well as take a look at a couple of functions. Thanks everyone, and I'll see you all in the next lecture.